Hello, yeah. So, so welcome to week four problem solving session. And this session, let's look into the problems we had in this week four. The assignments I have given. So, most of the assignments, if you see, these assignments are in there. It's a mix of comprehensive and numerical based. So, like there are these question number two, question number eight, and this nine problems. Actually, question number nine, it's not a numerical problem, but yeah, it's basically a theory-based problem. You need to go through those lectures and yeah, not lectures. I mean, if you go through those slides also, then also it will be you can answer this question. I mean, these are like straightforward questions for them. And so I will solve one problem related to this neural network one. And these problem, I think if fx is a logistic function, then f1 is, I mean, you can easily solve this function, right? You just need to put the values of x, and these are straightforward problems. And regarding this problem, the dynamic equation of one arm manipulator with mass and torque mental is given. I think PD control, so they have given this thing. They wanted to know which of the value, right? Which of the value will satisfy the equation, right? So you can easily get this answer. I mean, there is see like there is on this is the PD control, and you should know that whenever you apply some kind of a controller, it's a PD controller. All all the parameters should be positive. So based on that, you can answer those questions. And yeah, so which of the following is sigma? So these are math based questions. You can also solve. Then there is problems on table foot to a biped robot. Yeah, so this problem, I think you need to draw this, draw the box, draw that square and see if that if these given points are lying inside the point or not. These are like straightforward. So there is a, I mean, assignment man. I don't know as when I'm speaking, most of the problems are straightforward only. But yeah, but these problems, I think this problem can come in your final exam. So I will solve one problem, not the same one, but uh, similar one. And I think yeah, I think we'll start the I think recording. So let's solve the first question. So let's read out what the question says. So consider a neural network with one input X and two hidden layers and one output layer Y. Let Y be the let the sigmoid function will be your transfer function. So yeah, this is your transfer function. This is our transfer function 1 upon 1 plus e to the power minus x. The u1, u2 be the weights from input to hidden layer, and then v1, v2 be the weights connecting to hidden layers. If we have x equal to 2 and y equal to 10, so x is input and y is 10. And the learning rate is 0.1, and these are your weights v1, v2, v3, v4. After first iteration using gradient descent, what will be your v1, v2, v3, v4? Not v. It should not be v1, v2, v3. It should be something like yes, yeah. It would be something like there are two like so. This would be v1, v2, u1. So they are asking about the first iteration value. So how to solve this kind of a problem? First, we need to know how the structure of neural network look. So this is how it will look. So yeah, so this is our input. This is our output, and this is our two hidden layers. And this is the so the weights are u1 here, u2 here, v1 here, v2 here. So if you have any question, please do ask me. You can interrupt me at any time, and can ask. Right? So we need to find out what will be the after first iteration, right? And and they have said that consider null weight initially. So, so these are, so we need to get this u1, u2, v1, v2 value weights by doing some iteration using basically a gradient descent method. Okay. So first, let's see. So first, let's see what will be our final or the output function look like. So this is our output function. Okay. And so this is the desired output function which you can easily get it. I mean, so what you are doing is like this this part basically belongs to after so you will get something like here you will get 1x, it will be multiplied, right? And this sigma is your this function. So instead of x, just need to replace by something like 1 plus e to the power minus 2x. So after doing this operation, you will get this, and you need to multiply it with this weight. So here your y will be something like e1 upon 1 plus e to the power minus ux. So it should be u1x because this is right. And the other output which is coming here is this component. So this will be something like v2 1 plus e to the power minus u. So this is your y or your desired output will be, and you need to calculate this v1 v2 u1 u2 at after first iteration, right? So this equation you can easily get it. Okay, so I'm using the same equation which Professor Suwakana uh, was using. Okay. You can get, so this is your first so at zeroth iteration, at zeroth, this is your zeroth value. So considering it as a null weight, so I'm considering v1 v2 u1 u2 to be 0 0. Okay. And now after so we need to train the model. So during the training, during the first iteration, we need to use that equation. So this is, yes sir. So and so in order to train the model, we need to have some kind of a function. So this will be your equation basically, right? How do I get this equation? What you just need to go, you need to go to lecture 19, I think. So if you go to lecture 19, they have these equations. Like this is what the equation look like. This is for u and this is for v. Basically, what I done was like instead of writing u and v differently, I am combined it using something like this. So this is v, and so you see the u1 u2 terms are at the downward at the downward row. v1 v2 at the first and the second row. So this is what it looks like, where alpha is your training rate, learning rate. It's not training, it's learning rate, and dou e by dou v1, which you need to calculate. So how to calculate dou e and dou v1? So e is your energy, also not energy. E is your error, right? And this error function is given by fx by minus y. Okay, what is fx? Fx is your desired function which you want to like fx is basically your yk. So this y value which I'm showing is your fx actually. Okay, so you can consider it small y, and this y, capital Y, is your what you already know. So in our case, we already know in output which is 10 here, and input is 2. In input you always will be know, output also you will know, and based on that input and output you need to train your model in such a way so that it can predict at different time rate and all that. For this case, there is no time rate value, but this is what we know. Based on this input and output, we need to train our model. Not train, we need to model our output equation we are doing here. So you got the equation. So how to get this dou E by dou V1 and dou because V1, V2, U1, U2 is already 0, 0, 0. How to get that? So here, if you go to the lecture, Professor Suvakana has already given you this. So dou E by dou U1, right? So what you need to do is you need to first put fx as what you already know. So here what they have done here is A is the required constant. So here in case A is the required constant, y you already know. So if you do this something like A is basically 10. A is basically y. So this is your A, which is the desired value. And to approximate A using neural network Y, you need to replace Y with your whole this term, and they have replaced it here. And after replacing it, you will get something like this. Okay, and this thing they have replaced it with n square also. So when you do something like dou v1, right? So we have actually four term dou v1, dou v2, dou u1, dou u2. So when you just partially differentiate with respect to v1, you will get something like 2n minus 1 plus u1x. And when you partially differentiate with respect to the so u1 is here, v1 is here. So please do the partial differential carefully. And when you do it something like that, here that division rule will apply, and you will get the square term at the bottom. This is what you will get. Okay, and so yeah. So after getting that, so this is basically you will what you will get. And so what I did here is so you already know this, and there is alpha term, and 2n will come out, and basically what you will get is something like this. So the two row the first two row will be this one. Okay, so here instead of u1, so here yeah, so here it will come something like minus 1 upon 1 plus e to the power minus u. So this all this term here will be u0 because we are calculating about vn plus 1, right? And this is what something like vn, and this is something like alpha, and this is dv by uh yes by d, and all this is to happen at zero value. Okay, so capital V is something like a whole vector I'm talking about. So here it will be v u, should not be u, not u1, should be u0, and it should be x. Okay, so x value you already know, which is 2 here, which is given in the question. But u not you know, which is 0 here, right? Okay, so this term is 0, 0, 0, right? So when you put this term here, will it will be this will be 0, right? This whole term will be 0 because no, not be not be 0. It should be something like b minus. So not be 0. Yeah. So when you put something like 2x, it should be u1. U1 is 0, so x will be 0. So yeah, it should be half. So should be minus half. Should be minus half here again because instead of here there is a u1. So this is something like 1 here, something like u. This is for small v1. Do it for small v2. Will again get the same value, but instead of u1 you will get u2 here. So u1 we are taking, but we are taking the initial value. So again you will do the same thing, you will get again half here. And when you do it for, let's say, u2, so this mega is u2 here actually. Okay. When you do it, some you will get something like this. And when you put this u1 0, what you will get, this is I, e to the power 0 is half, right? So what you will get, so this is v1 is 0, right? v1 we are taking 0th. So I'm filling up this part. Okay, this is v1 is 0, you already know it. It will be 0 all. You multiply it with all term, it will be 0 here again, 0 here. This is what you will get. So professor has already solved one problem here. If you look close here, you see they have already solved this kind of a problem for you. Please look into this problem. So like here they have it. So here they have already calculated -1 and -1. But I think it's wrong. It should be minus by 2. Because if you put initial values to be 0 like this, what you will get? You put initial value should be 0. So it's because they have taken this 2n out. What 2 into n is basically 5 minus 0. What 5 is there? A is 5 and this is 0 0. If you say something like this, one should be 0, because if you want first iteration is 0, zeroth iteration is 0, so it would be one. It should be minus half. They have taken it wrong. It should be not 1. It should be 1 by 2. Okay. Yes, but we can do the changes. For in our case, should be half and half. So I need to change it here again. You will get -1 by 2 here, -1 by 2 here. There is this 2n term. Okay. So this 2n term you can 2, but how to get n? So n is basically your this whole thing. Okay. Where a is, you already know, a is 10, is given in the question. And when you put iteration 1, okay, so this v1 zeroth iteration will be 0 here only. So it should be 0 minus 0. So n is basically 0. Sorry, n is basically 10, not 0. So should something, so when you do the calculation, it will come out to be 0 0 0 0 minus, and this will be half again. When you do this thing, you will get b minus 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 b plus, and when you do the whole thing, it should something like this. So it should be 1 1 0 0. Okay. So answer here will be 1 1 0 0. Okay. So I have here I've taken that. Yeah, should be not -2, should be 1 1. So answer here is 1 1 0 0. Okay. So in this way you should yeah, you should proceed with these problems. Okay. And yeah, I think that this is the first problem. So we need to solve that problem which is given here. You need to solve this problem in the same manner which I have done it. Okay. So here in this case it's 1 minus e to the power x. Okay. So please be careful when you solve this kind of a problem. So in my whereas in my case, transfer function which I am taking is 1 plus e to the power minus x. Whereas professor has taken is also 1 plus. Please be careful when you do those calculations. This is actually a sigmoid function. Okay. So yeah, so please be careful when you do something like all those calculations. So yeah, so this is how you will solve those problem, and this is the solution. So coming to the next problem. So this problem, let's read out. It's regarding the stability problem. So uh, if ml square, so it's uh, ml2 theta double dot plus mgl sine theta is equal to tau. So this is basically a single link pendulum problem. The dynamic equation is given to you of a single arm manipulator or a single link pendulum. And if tau, so they have already given you what is the torque value. If tau is mgl sine theta ml2 k1 theta plus k2 theta dot. Okay, please uh, that correction. And is a control. So we are taking tau as this, and so that theta and theta 2 dot. So theta and theta 2 dot tends to 0 as t infinity, then what will be the condition? So what they are asking is at time equal to infinity, or this theta and theta dot will tend to 0. This is so these are basically the state of the system, and these are going to 0 at time equal to 0. So what will be the condition that uh, that will so what will be the condition that will allow this uh, allow the state function to go to 0? Basically, they're telling that an asymptotically stable system. So what are the condition it should be met in order to say that the system is asymptotically stable? So first we need to uh, write our dynamic equation, and this is what the dynamic equation of a single arm manipulator look like. And we need to write what are the states. So there are two state. One is theta and other is the theta dot, right? And when you differentiate this, you will get something like theta double dot, right? And you can replace the theta double dot by tau minus mgl sine theta by ml square, right? So you are converting this single degree double second order differential equation to a single order differential equation. And in the question it is given that yeah, so the question it is given that tau is here. So tau value has given the controller which we are choosing. So when you put this tau value in this equation, when you right, so you will get something like right. So you will get something like k1 theta plus k2 theta dot. Okay, and based on this, you need to tell us what will be the theta. So here they have given here. So they are telling that both of them will tends to 0 when t equal to infinity. So here you see there is only the second order differential equation. It's a second order, yeah, it's a second order linear differential equation. So what you can do is you can easily solve this equation. I think you have already solved this kind of problem in your mathematics in your first year of it. And when you do this, you will get something like this equation. And now and for that, for m1 m2, this is what you will get. And if you look closely to this equation, it's what it would what it says, right? It's basically, yeah. So how to solve this kind of problem? Basically, minus, yeah, equal to 0. That is like minus b by 2 plus minus b square minus 4ac. So B is here basically minus K2. Right? That's what we are saying. That's why here there's K2 by 2. And so this is what you will get. Okay. And how to solve this kind of a problem. So we need our theta. We need our theta to go to infinity at time t equal to we need our theta to go to 0 and time t equal to infinity, right? And how to do that, right? Let's say if we have uh, like c1 the power minus a real term, let's say it has a real term which is alpha t. I don't know about the other term which is something like a beta. Beta can be I also, it can be something like that. Let's say it can be imaginary or it can be. So if you say something like this, minus term is there, and when you put t equal to infinity, then automatically it will go to 0, right? Yeah, it should go to 0. And yeah, so how to say that what will be the condition it should satisfy? Let's say if this value k, k2 square minus 4k, it goes to, let's say, 0. 0 is also good, goes to 0, but we need a k2 to be something which is should be negative, right? K2 value should be 0, right? When it, because this is the real part. But let's say if this is greater than 0, which is right. So there might be a case where the addition of both will make the whole empty to be positive, which we don't want, right? We want something like e to the power some, and then if there is a beta term, then that will be resulted into sine and cos term, which is okay with us. But we want t to be something higher. Very we want alpha to be negative, right? So how to do that? In that case, k2 should be negative, and this value should be less than 4k, less than 0, k2 square. If it is less than 0, then that will make the system imaginary. So there are two components, but that imaginary component, if you solve it e to the power, let's say it, then that will turn out to be like SAS t1 sin it sin t plus cos t. So imaginary part, so the sinusoidal part we are not worrying. We only want the real part to be negative. So that will only happen when k2 k2 should be less than 0, and this k2 square minus 4k1 should be less than 0. So this is a simple problem. This is in this way. So this problem was asked in the last year. So please do solve. Be careful. Carefully solve this kind of a problem. And so there is this last problem. I think you can easily solve this kind of a problem. But let's see if he has any. So yeah, man. So this is our last problem. So the answer has been given. So I think I need to change this options here. So yeah, option will be A, but K2 is greater than 0, but K2 should be less than 0. Then only that will make sense. Okay. Yeah. So here you need to find the inverse of a Jacobian matrix. So I mean that seems simple, right? How to find the inverse of a matrix, but here the problem is like it's not a square matrix. So inverse is only possible for a square kind of a matrix, but right. But Professor Suvakana has already taught you that for kind of a Jacobian matrix, you need to find something called pseudo Jacobian matrix, pseudo Jacobian matrix, right? So here you just need to apply this formula, right? There's nothing which you can do. Plus, please do remember this formula. This formula is important. Can you can easily ask this problem. So like need to transpose this. I have did here. and then there is J into J transpose. I need to take an inverse of it. What I did, I have to multiply this J into J transpose. From there, I will get that square matrix, and the square matrix we can inverse it by calculating the determinant and also that. So please, yeah. So this is a lengthy problem. This lengthy problems, they won't ask you, but please do instead of uh, one cross this T cross three, they will ask, let's say, one cross two. So they can ask that kind of a problem. So please do remember this formula, and this is what you will get for getting answers. So yeah, so this was about this week. Let's just go through. There any problem? This problem also looks quite easy. So yeah, Jacobian. So you just need to go through your lecture notes. Uh, so lecture notes all will have the answers. Please do refer the lecture notes for this kind of a question. Then coming to week five, I think week five also Human Arm Robot has a dash degree of freedom. Yeah, so these are I think most of the problems look like comprehensive type. I think just need to listen the lectures because I think from now onwards, I think there will be more. The lectures are more on the research aspect. Okay, so you don't need to go through the complex mathematics part because all the I think the exam is there is some numerical ability questions are there, but I think the exam doesn't have any subjective part. For other NPTEL courses it has, but I don't know about this. Mostly they don't ask that subjective based questions. So I think this was about week five, and yeah, so please take care of it. I think you just need to refer, and please download these lecture notes. That will be please download these lecture notes. Okay, that will be handy for you. So because as week progresses, this you will forget some of these formulas and all that. So please refer the lecture notes, or you can make your own some kind of a formula paper where you can get it out. What are the so that you can revise it. But these lecture notes are handy in that. So this will help you so that you won't have to go again. You won't have to solve the problem again and again, or you won't have to watch those videos again and again. So refer those. That was it about. There any question? And regarding books, there's this book, but I think this book is basically what the professor has taught you in this. There is no perfect book for it, but you go to thing like about the course. So if you go to something like about the course part, there are some books which are referred here. So there is book by this Richard Paul. Okay, so please do refer this book. So the book which I've told you, they uses a different kind of method uh, to solve those DH parameters. So to solve those transformation matrix in order to go from the zeroth link to the defectors, they use a different kind of a DH parameter formula. Please refer this book. I think Richard Paul. I think there is no soft copy available in it, but you can easily get this copy by using a LibGen. So the LibGen is a website where you can go and I think LibGen can times I have this. I've downloaded this using thing log. Okay, so this is not Richard and Downloaded using a libgen, so there was a different site for libgen. Uh, these are the libgen website which are pirated. Not pirated, but these are the website where you can get the books. Please refer those books. I have this Richard and Paul book. I think I will show you how this book for this book, but I think it's also a half read book. So I've got for the book, and you don't have to go through each and every chapter, but only the chapter which professor like homogeneous transformation, trajectories, and differential relationship. I don't think so. Control part you may choose. I think the page. So I have a page up to 92. I think they already there. Let's go to the control part. What they are talking. Uh, yeah. So these are the Stanford manipulatory equations, the joint stocks. So yeah. So you can refer this. Please refer this book. Okay? Because there are some problems which will be helpful for there because you will find some problems solved here. Okay, that can help you because this was the primary book which was referred, which was given actually. This book, please refer this book if you find something like Robert Schilling's Fundamentals of Robotics. Then also it's good. I think I have not gone through that book, but yeah, you can refer this. And these books are from the professor itself. So these books basically these are research papers. If you are interested in the research part, you may refer this papers. Yes, and I think yeah, that was it. That was the today's session. If you have any question, please do ask me. So guys, yeah, so this was uh, for the week post session. Yeah, if you have any question, to ask me. I think next session will be about hand manipulator, the hand manipulator. Week 5 is all about human fingers and hand and the fundamental robotic manipulation. I think this from this week onward, Professor Felix uh, will take over, and yeah, I think yeah, it's 9:40, 9:42. I think I mean, there's nothing much to tell you in this week because if you look to the questions, most of the questions are theory based, so which you can easily get it. So there's no point to it. I'm more interested on that numerical part. That's why I'm going through it so that I can easily solve those problems. Okay. But, yeah, so I think I will end the meeting. Have any doubts? Please do ask. Please do use that Google forum. You can use this question and a forum.